All the weirdness of relativity arises from the second postulate. A postulate, a fact about our universe to be just accepted or understood intuitively. Hello, I'm Dr. Nitish. This is Intuition, and today it's about the two postulates of relativity. Let's look at Einstein's original words and their English translation. This is the first one in German. I will not read it, you can pause and read it, which translates to this. The language is dense, like it used to be then. Now, this part can be summarized as the laws of physics are unchanged, and this as for two inertial systems moving relative to each other. And this is the second postulate, commonly paraphrased as the speed of light is independent of the speed of the source. Let's take the first postulate first. The popular interpretation is that all motion is relative, or there is no absolute motion, just like Galilean relativity. Remember Galileo's sailor in a ship's basement? It's here in my video about the history of relativity, who couldn't know whether the ship is sailing or still, because no experiment can differentiate between rest and inertial motion. Galileo was talking about mechanical experiments only, because those were the only ones possible at that time. But Einstein, with his second postulate, brought electromagnetic experiments under this law. Now there was no way to know whether you are moving or not. But you see, in a way, the second postulate is to be accepted here and used to explain the first. And this is the reason why relativity is not intuitive to us. For 120 years, we are told to just accept the second postulate, when we should have tried to understand if there is a more fundamental reason for a constant C. Before stating these two postulates in the same paper, he discusses the magnet and coil problem. Whether you move a magnet near a coil, or the coil near the magnet, or both, the same current is induced in the coil proportional to the relative speed. If the relative speed only matters, why should we think about the electric and magnetic fields then? Even if some type of a field or ether is there, it does not show up in any way, not even in experiments designed to detect light speed, like the Michelson-Morley experiment. The adjective Einstein uses for ether is superfluous. If there is no ether, there is no experiment possible that can show absolute motion, the motion relative to space. But this is a weaker statement of this principle. We need a stronger one. Instead of saying no experiment can show absolute motion, we have to state every experiment will show that you are at rest. But this is still not enough. The correct phrasing should be every inertial observer is at rest. That's it. Too strong. Let's do this thought experiment. A rocket underwent acceleration at 1 g for 10 years. What's its speed now? No need to calculate. Just tell me, what does the astronaut need to do to achieve complete rest? Yes, you guessed it right. Just switch the engine off. It's at rest in an instant. If it collides with something, there will be great damage because there was a relative motion. From our point of view, the rocket was at a great speed, but for the astronaut, that asteroid was speeding, not him. Okay, I think we have grasped this. Let us move to the second postulate. The speed of light does not depend on the speed of the source. Let's look at this supposing light is a particle. In classical mechanics, if Ben is moving at v relative to Alex, the ball Ben is holding is also moving at v. Now, if he throws it at a speed u relative to himself, Alex sees it moving at v plus u. But Ben can't hold a photon. He may hold an electron and a positron, which are moving with him at v all the time. No deviation from classical physics till now. Now, when he connects these two, a photon is produced. That photon was not moving at v till its birth. It just wasn't there. So it is not carrying over that velocity v. It just moves at c. For everyone, a photon speed is independent of the source. But what if light is a wave? Let's see what happens if it is sound instead of light. A jet is flying at a speed v. It produces a single sharp beep at this instant. That beep moves at just the speed of sound s. It doesn't move at s plus v. Wave speed is independent of the speed of the source. It is only relative to the medium. But the jet would measure the speed of sound as s minus v or s plus v. If it is supersonic, this speed can even be negative. If you observe this from the ground, this would be your observation, because the jet is moving relative to air, but Ben isn't moving relative to the medium of light. So he will measure light speed as c. Everything is at rest. Only light moves. That is why c is the same for everyone. And Alex will see light speed c, but light speed relative to Ben as c minus v. This is at the heart of relativity. Everyone measures light speed c, but everyone also measures a different light speed for everyone else. This leads to the same Lorentz transformations by a different mechanism, by making time appear to slow down in frames moving relative to you. We shall see that in the next video. Stay tuned. Please comment on the video. Let's have a conversation. Take care.